It takes an amazing amount of software and hardware working together to make a network function. So the challenge to all this is that if you have different pieces of software and hardware, they all have to be able to talk to each other and interact and able to make your network go. You might have a network card from 3Com and you might be running a Windows 8 operating system, and all of these devices have to work together. To help make interconnectivity work, they came up with something a long time ago called the OSI 7-layer model. The OSI 7-layer model is 7 distinct functions that a network must do. Now the OSI is being supplanted with something called the TCP model. So let's do a quick overview and take a look at OSI and TCP. Now for OSI, we're going to start, basically there's no real bottom or top, but I tend to look at it at the bottom, which is your most basic part, which is what we call the physical layer. The physical layer that's like the easiest part of the OSI 7-layer model. It's just what type of cables do I use and things like that. Now, coming up from that is the data link layer. Now, the data link layer is a little bit more important. Basically, anything that works with a MAC address works at the data link layer. So when we're talking about data link, we start talking about things like the network cards themselves, start talking about switches, things like that. The third layer is the network layer. Now, the network layer is important because the network layer has to do with logical addresses. So when you see the network layer, you're talking about IP addresses. So things like routers in particular work at layer 3. The next layer up is the transport layer. The transport layer is kind of interesting. Data is big, and the actual chunks of data that go through a network are relatively small. So there has to be an assembly-disassembly area for data as it gets broken down into individual packets, and that's what the transport layer is all about. The transport layer not only disassembles packets, but makes sure the packets get to the other system in good order. Next one is the session. Now the session's kind of interesting. When we work at a session layer, here we're talking about the actual connection between two systems. Are we making a TCP connection between a web server and a web client? Are we just sending email? Are we sharing a folder between two computers on a local network? And it's the session layer that defines what's taking place in terms of how that connectivity really works. Next is the presentation layer. The presentation layer is old and weird, but since it is on the OSI, we need to at least make a quick mention of it. Just because a big chunk of data comes into your computer, does that necessarily mean that this data is in a form that your computer can read it? Now, let's use a Microsoft Office as an example. If I open up my Microsoft Office, I can open up almost any kind of document you can dream of, and Office has the smarts built into it to automatically read it. But that wasn't always the case. So the presentation layer used to be used to convert data into a format that your applications can read. Up here at the top is applications. Applications is important because it's the applications themselves, and it's not really the applications. You have to be careful here. What we're talking about is the smarts in the applications that make them network aware. Little simple things that you and I never think of. For example, if we were to open up Microsoft Word and we could literally go to the network to go find a particular file. And that's because Microsoft Office itself is network aware. We often use the term API, or Application Programmers Interface, as the definition of the smarts that are built into an application that allow us to make the application network aware. So this is the OSI. All right. The TCP/IP model is more simplistic than the OSI simply because if you're using only TCP/IP, there's a lot of parts that don't really come into play as much. Let me show you what I'm talking about. First of all, we have what they call the network interface layer. So the network interface layer covers all the physical cabling, MAC addresses, network cards, pretty much everything in terms of hardware with a couple of small exceptions, routers, are all covered here under network interface. So that ties similarly to the data link and physical for the OSI. Now your next one is your internet link. Your internet leads for IP addresses, so things like routers or anything that has to do with an IP address works at the internet layer. The next one is transport. Now transport does all the assembly and disassembly, but it also has to do with whatever it takes to connect to the other system to make sure the data gets there. So in this case we're talking about things like, for example, TCP or UDP, whatever it takes to get those chunks of data from one application to the next. Now, the last one is called application. So application actually takes into consideration the old OSI application, presentation, and session layer. So everything that has to do with the application itself works at this layer. Now you keep in mind that the TCP/IP model looks at this a little bit differently than OSI. TCP model looks at applications as applications. For example, email or FTP or Telnet, all of these very distinct things that each have their unique port numbers all play into this one particular area. So if it were up to me, and it's not, but to me, I would change this a little bit. First of all, I would go ahead and take the transport layer and put the old OSI session layer into that as well as the transport layer, but that's really not the way we look at it for the exam, so let me put that back. And that's pretty much your TCP/IP model. Now, what I want to do is let's take a look at both of these guys. First, we have the OSI model, older, more detailed, and then we have the TCP/IP model, more modern, not as much detail, but not as complicated. Make sure for the Network Plus exam that you know both of these models. Now don't worry about it. We've got a lot more to talk about. We've got lots of episodes that are going to break down all the different layers in these models in a lot more detail. But for right now, the important thing you need to appreciate is that each one of these layers has a distinct function. Each one of these layers has a name, but not only that, it's also got a number. So let's use OSI as an example. If I'm talking about OSI and I'm looking at the network layer, now understand it's network layer, but there's also numbers associated with it. They go from 1 up to 7. So if I'm talking about OSI and I say layer 3, you need to know that I'm talking about the network level. That's also very true with TCP/IP. So whenever we're talking about the TCP/IP model, there are numbers associated with it. Make sure for the Network Plus you know each name of each layer as well as the number associated with it.